So hey guys, welcome to the channel Learn Competitive Programming with CodeChef. So if you are new to the channel, then this channel brings out to you quality content over data structures and algorithms, competitive programming and video tutorials for the CodeChef contest. So if you are new to the channel, then do subscribe the channel. Myself Chirayu Jain, I'm a CodeChef educator, and in today's video we are going to discuss on the topic Doubly Circular Linked List from the series Linked List. Okay guys, so now let us understand the concept of doubly circular linked list. So let's go with the definition first. So doubly circular linked list, as the name indicates, it is the combination of doubly linked list and the circular linked list. So if you've not watched these two things, it's a recommendation to watch these two things, then move on to this, right? So doubly circular linked list has the property of both the linked list, that is the doubly linked list, and the circular linked list, right? So what are those? Two consecutive nodes are connected to each other by the previous and the next pointers, as we have seen in the doubly linked list, and the first and the last node are connected to each other, as we have seen in the circular linked list. So basically the first node previous pointer will be pointing to the last node, and the last node next pointer will be pointing to the first node, right? So here in this particular case, right? So as you can see in this given diagram, this is a typical representation of doubly circular linked list, right? So what we're trying to do here, each and every consecutive node you can see here are bidirectional, right? They are connected to each other with the help of next and previous pointers, and the last node, as you can see, the next portion of this is connected to the first node, and the previous portion of this is connected to the last node. So that makes it circular, right? So this is how we just get to the basics of circular linked list or doubly circular linked list, and this is a typical representation. This denotes the front node, this denotes the end part, and we need to look up the things, right? We need to understand what are the multiple operations that we can perform on this doubly circular linked list. So that now we'll proceed to that. So this is the basics which is clear what is doubly circular linked list, and now we'll quickly move on to the understanding of the operations about insert, delete and search, and then we'll move out the coding. Okay guys, so now let us understand the insertion, deletion and searching of a node in the doubly circular linked list, right? So there are standard these three operations that we are covering in all types of linked list, and let's see what we can do here. So till now we have a good knowledge on circular linked list, doubly linked list and the initial single linked list, right? So we have so much understanding. So now let's try to use that. Okay, but these different situations where we have bidirectional connections as well as the last node is connected from the first node, that is doubly linked list plus circular linked list. So how we can just try to implement these operations in these, right? So let's say that we need to have insertion in this. So all the possible categories, like we can insert at back, we can insert at front, the corner conditions when there is no node in the linked list, when there is a single node in the linked list, all that will be covered, right? So here what I am doing is I want to insert, let's say, a new node at here, right, at the back. I want to insert a new node. So what I can do, all the conditions, the logical way of approaching a problem, right? So now what we have is this is the last node, right? And we want to insert this node, right? So this last node has the next pointer connected to the previous of this, and the previous of this is connected to this particular node, right? So the last the next pointer is connected to this node, and the previous of this is connected to this node, right? So first of all we need to modify it, right? So what we can do is we can just remove these changes out, and what we can do, we can build these changes here. So the next of this will point to now the first node, and the previous of the first node will point to here. That's all what we can apply here, right, while inserting a node. One more thing, since it is an insertion, so the next of this, right, next of this, instead of pointing to the first node, it should point to this node which is newly inserted, right? Correct. So this is one of the possible case that we can have it, right? This is one of the possible case we can have it. Also since it is bidirectional, so the previous of this should point to this, right? So here the two links are created for this node, right, and here the two links are created for this node, right? So this is what we are trying to achieve over here. Same going with the standard approach and building up like what we have learned throughout in this series for circular linked list and doubly linked list, right? Similarly, if we want to insert a node, let's say here, then we need to develop these two pointers, right? And with these two pointers we needed to develop the pointer with the last node and the next of this last node. That means four links we need to have it, right? And also we can modify, if this is the head earlier, then we will modify the head to here. This is all what we can think of, right? Insertion and all. Deletion, the same process. There are cases in which, let us say, if we are deleting the node which is present at the end, we are deleting the node which is at the present, somewhere in the middle, all the possible cases needs to be considered, and simply what we will do, we'll modify the pointers, right? We will modify the pointers. So basically in each step we are trying to modify the pointer while insertion, deletion or searching, right? Searching just involve like checking only. It does not have any impact on like we need to modify the linked list, but simply we need to check it. But majorly in insertion and deletion we need to just modify, okay, the next and the previous pointers needs to be modified for that. So if we see deletion as well, so most of the things will be cleared out when we see the code. But if we logically think for deletion, what we can do, right? What we can do, let us say if we want to delete this node, right? So what we can do, the reversal of insertion that we have done, right? Most probably we need to make the next pointer of this pointing to the next of next. So next of next is this one, right? Next of next is pointing to the first node. So this pointer, the next pointer will be now pointing to the first node, right? And the previous of this should also point to this node, right? The last should be updated here, right? And then we can free out this memory, right? So this is how the simple steps have been done. But for all the cases, for the corner cases, such as if there is no node present, if there is single node present, we need to take care all of these situations, right? That's all we will see in the code. And searching a node in the doubly circular linked list is also very similar, right? But here, since it's a doubly circular, so we need to track the point whenever we are starting and again encountering the same node, right? If the node is visited, then we'll not enter the circular loop again, right? So there is no concept of like, if there are nodes in the circular linked list, then there is no concept of null, right? We need to track, okay, we have again reached the start position, then that it means that we have completed one circle, right? In either of the bidirectional way, right? So this is the important case here. So we need to take and combine all the properties that we have learned in doubly linked list, all the properties that we have learned in circular linked list, and combine them to produce the results in the doubly circular linked list. So these are the three operations. We have just seen basics, extreme basics, with the help of this diagram, that what we can do. Now let us directly jump into the code and understand each and every point in great detail. Okay, so now let us take and understand the insertion function first, and then we'll proceed with deletion and searching. So let's start with the insertion. So this function is insert at the end. We want to insert the node at the end. We have the starting node. Okay, from this doubly circular link is starting, and we want to insert at the end. So we have provided with the reference of start and the value, right? We have been given this. Now what do we need to check? First condition is if start equals to null. What is that condition? That means there is no node present in the doubly circular linked list, right? So if there is no node, that means the start is null, it is pointing to null, right? So we'll create a node. We have created a new node, and we'll first make the data, right? So the data of the new node will be the value that we have in the arguments, right? Now the new node next will be equal to new node previous will be equal to new node. That means the next and the previous of the new node will be new node only, right? Because it is a circular linked list, that means the new node should have the next pointer pointing to himself only, and it is a doubly linked list, that means it should have a previous pointer as well, that ought to be pointing to the new node only, right? So we have written the combined condition that both of them will point to new node, right? That's what is different from the double linked list and the circular linked list, right? Because both of them are combined now. And we'll make the start as new node, because there is now a single node entry in the linked list, so we'll make a start as new node and we'll simply return. This is the condition when the linked list is empty, right? Now if there is certain elements in the linked list, if there are certain nodes in the linked list, then what we will do, right? So we need to insert at the end, right? So first of all, what will be the last will be the previous element, then from the start, right? So we'll make node last equal to start previous, because the previous pointer of the start will be pointing to last. So we have done that, right? We know, okay, this is the last element, right? After that we need to insert, after last and before start, we need to insert one element, right? So we have created a new node and we have entered the data for it. Now the new node next should point to start, the game of pointers, right? We need to just change the links, right? The new node next should point to start, right? The start previous should point to new node, right? So we have done with the connection of start and the new node, right? The new node next should point to start, and the start previous should point to new node. We have done with the connection of that. Now we need to change the connection of the last node and the new node. So new node previous should point to start now, or should point to last now, right? New node previous is pointing to the last, and what we need to do, the last next should point to new node, right? So these are the changes in the pointer, as we have discussed in the the theory section. We discussed that what 4 things we need to change. So we have done with this in this 4 steps. That's all. The insertion at the end is done, right? Similarly, we will do the insertion at the beginning also, and it's your work to write insertion at any nth, after any nth node, right? That you can easily do, I guess, right? So now let's move with the insertion at beginning of the doubly circular linked list. So again, we have provided the start node, we have provided the value. Now what we do, we need to insert at begin, right? So we have taken the last. What is the last? Start previous, right? That's okay. And we are making a new node, right? That is with this node, new node equal to new node, and then the data inside that will be equal to value, right? That we have in the arguments. Now the game of pointers again, 4 steps, right? So new node next should point to start, new node next should point to start, obviously the same game, and new node previous should point to last, the same game, right? Because we are inserting again in between the last and the first node, right? It is circular type. It is not that it is not connected at the end. It is a circular, so the position will be intact only. So if you see these steps, they're almost similar, right? They're almost similar. So new node next should be pointing to start, new node previous should be pointing to the last, and the last next, right? The last next should be pointing to the new node, and the start previous should also be pointing to the new node, right? This is the new node, the last next should pointing to the new node, and the start previous should be pointing to the new node, right? So this is, we have combined here, right, these 2 things. And the important condition over here is we'll update the start. So these 4 steps are done, and now what we will do, we'll update the start, because we need to have the start pointer at the beginning only. The start will be equal to new node, right? So this is what the change we are doing in the insertion at beginning. So we have discussed both of the things. Now let us discuss the deletion. Okay guys, so now let us discuss the delete functionality in the doubly circular linked list. So similar to the insertion, we have a delete node function which consumes start, that is the starting point of the doubly circular linked list, and the key which we need to delete, which you need to find that, okay, this node has this key and we need to delete it, right? So the first thing, we'll see some of the conditions here. What are the critical points that can be touched through this functionality? So if start is equal to null, then we'll return. Why? Because it is the empty doubly circular linked list, right? So if start is null, that means there is no node, right? So that means that we cannot delete anything, so we'll return. Otherwise, we'll make 2 node pointers, that is current and previous. So that is previous one and current. Current will initialize it with start, and previous one as null. So while current data is not equal to key, right, till the point where we do not encounter a node with the value key, we will continue this loop. And when we can break, so when current dot next equals to start, what this particular condition means, if we have seen the circular linked list, then whenever we again encounter start, that means we have covered the whole circular ring. That means our one iteration is complete, right? That means that there is no node which we have encountered with the value key and we cannot delete anything. So we'll simply say that, okay, no node is present with this value, and we will return, right? So this is one thing. And with the each iteration, we'll update. If this condition is not met, we'll update our previous and current pointers. So previous will be now equal to current, because what is previous? Previous is just one node prior to current, and current will be equal to current dot next, right? So that is the case where we encounter whole circle and we do not find any node. If that is not true, if it is not returned, that means we found the key, and that key is current, right? The node is current. Now let's see what all possible cases do we have if we found that particular node. One possible case, that only that node is present inside the doubly circular linked list, so we are taking it here. So if current.next equals to start, that means the next position is start and the previous is null, right? There is no previous and the current.next is start, that means only single node is present, because there is no previous and the next pointer belongs to start only, that means only one node is present. So what we will do, we'll make start as null and free that particular current node and simply return, right? So now the whole doubly circular linked list is empty. Another possible case, if current is equal to start. So this possible case is when we need to delete the first node, that is if the current is belonging to start. So obviously previous will be prior to that, so previous will be equal to start dot previous, right? The last node, and the start, we will increment the start as start dot next, because we need to delete that particular current node. So start will be pointing to its next, and then we'll update the pointer. So what pointer we will update? Previous one dot next will be equal to now the current start that we have, the second node, right? Because the first node is going to be deleted, and the start of previous, right? The previous of that particular start will be now the previous one. The changes in the pointers, the game of changing the links, and we will free the current. That's all, right? So if this is a first node, what will happen if it is the last node? So this condition is taken care over this. So if current dot next equals to start, that means that it is the last node, because the next node is the start one, right? It is the last node that we need to delete. So what we will do, we will make previous as previous one dot next as start, right? So previous one dot next as start, we will make it, and start of the start previous we will make at previous one, right? So if we want to delete the last node, the only thing is the previous one, right? The previous one dot next will be pointing to the start now, because the current we need to delete it, right? So current will be one step back, the previous one will be one step back, the current one, that will now be our last node. The previous one will be our last node. So what we will do, previous one dot next will be now the start. There will be no involvement of current into that, and the start previous one will be the previous one. The start previous will be the previous one, right? Because the previous is another pointer that we're taking, so that we named as previous one. So the start previous will be pointed to previous one, that is second last node, right? Previous one is the second last node, current is the last node, and we need to delete the current, right? And then we will free the current, so that there will be no involvement of this last node now. Otherwise, what we will do, if that both cases does not fulfill our conditions, so what we will do, that is there is some middle node that we need to delete it, right? So we'll make a temporary node variable, that is temp, and we'll initialize it with current dot next. So temp is now pointing to the current dot next, and previous one we have, that is current prior to current, right? So just we need to add the pointers to this temp and previous one, and we'll free the current. So previous one dot next will be pointing to the temp. Earlier it was pointing to current, but we need to delete current now. So previous one dot next now will be pointing to temp, and temp dot previous will be pointing to previous one, and then we'll free the current. There are multiple approaches which you can think of, like do not include this variable temp, just write here that if previous one dot next will be equal to current dot next, right? And current dot next dot previous will be equal to previous one. That's up to you. You can come up with multiple approaches, and that's what we want here, right? To develop a community where we can just write our own approaches and tell us, okay, this is something more efficient, more useful, so we can discuss on that as well. So if you feel, then you can write it down. Now that delete functionality is complete, now let's quickly look at search functionality. Okay, so now let's start with the final functionality, that is search functionality, right? So we need to search a particular value, and this is the start node that we have. So we made a temp node, right, and initialized with start, and we are making a count variable, a flag variable, and the value, right? So now let's see what are the usage for this. So if temp is equals to null, that means we return -1. If temp is only null, that means there is nothing to search of in the linked list. There is no linked list present, so we'll return -1. Otherwise, what we will do, while temp.next is not equal to start, that means we are not covering the whole circular loop, right? Until that particular point we'll make count plus plus, and if temp.data is equal to search, right, the data that we are getting inside the functionality, if that is equal to the data that we are traversing in the linked list, then we'll make flag as 1, right? That is simple flag, and we'll decrement the count, right? We'll decrement the count because count was incremented here, and we'll break out from the loop. And for the continuation process, we'll make temp equal to temp.next, right? So that we can move on to the different nodes. Okay, so now if temp.data is equals to search, right, if temp.data is equal to search, then what we will do, we'll simply increment the count again, and flag is equal to 1. So why we are using explicitly this condition outside? Because here what we are doing is we are making temp.next is not equal to start. That means that the last node will not be encountered here. So if whenever we will go to the last node, then what will happen, the last node dot next will be equal to the start, and will not execute this condition for that particular node. So for that particular node, we'll see that, okay, if the last node is equal to search, then what we will do, we'll increment the count and we'll make flag as 1. Otherwise there is no node which was found. So if flag was 1, then we'll return the count, okay, at this particular index or at this particular position our node is found, otherwise it is not otherwise it is not found. So that is a simple functionality, and I think we are not using this. This is just one. Okay, so that we are not using this value. This is a simple functionality that we have written for finding a node inside the doubly circular linked list. So I think any type of linked list can be given to you. I think with some drawings and understanding, you can develop your own logic and just write the functionality. It is not just that memorizing the stuff, it is logical thinking and just implementing it. So I think